Hey guys, today let's solve the Koko Eating Bananas problem. So this is the given problem, right? There are n array piles where each element represents how many bananas on each pile. There are integer heads which represent how many hours that Koko have to eat all bananas before the girl come back. The eating speed are represented by k, and Koko only can eat one pile at a time. Well, what we need to do is to find the minimum eating speed for Koko to eat all bananas before the girl come back. Let's take a look at the example 1. So the given pile is 3, 6, 7, 11, right? And we have 8 hours. Let's say we start from the eating speed 1 bananas per hours. We need to use math.cell. Then we need to look through the given pile, right? This will be 3 hours. Total time right now is 3, right? We move to the second pile, which is 6. This will need 6 hours. Total time right now is 9 hours. Too slow, right? Because the girl come back in 8 hours. So we need to increase the speed. Let's say we eat 2 bananas per hour. I need to copy this. This one is 2, this one is 2 hours, this one is 3 hours. Total time is 5. Then we move to the next pile, which is 7. 7 divided by 2, we need around 4 hours. Total time right now is 5 plus 4 is 9. Too slow. So we increase the speed again to 3. I need to copy this. This one is 3, 3, and 3. 1 hour, 2 hours. This one is 2. This one is 1. 1 plus 2 is 3. 3 plus 2 is 5. We move to the last pile, which is 11. We will need around 4 hours. Total time right now is 9. Too slow. We increase the eating speed again, right? Let's say the eating speed right now is 4. So this one will be 4. So this will be okay. Even though the eating speed is 4 and the first pile is 3, right? Koko will still spending 1 hour to eat the bananas, the 3 bananas. That's why we need to use math.cell. So the first pile we will need around 1 hour, right? And on the second piles we will need 2 hours. On the third pile we will need around 2 hours as well, right? And on the last pile we will need around 3 hours. So the total time is 8, right? This is the ideal eating speed. Well, like I said, why do we use math.cell? Because even the eating speed are 4 bananas per hour, Koko will still spending 1 hour to eat the first pile, which is 3 bananas. It's already mentioned on here. Koko likes to eat slowly but still want to finish all the bananas before the girl return. That's why we need to use math.cell to round up the total time that needed, right, to eat the bananas. Okay, I think I will just delete this first. And let's turn them into the code. This is the brute force solution. Cons minimum eating speed. The first one is pass. hours. So we start from 1 hour, right? Start from eating 1 bananas per hour. Then what we need to do is, I think we can just do this. For let k is 1, which means we start eating from 1 bananas per hour, right? And k is smaller or equal to max pile is mat.max piles. Max piles k plus plus, that means we need to increase the eating speed, right? Then we need to look through the piles for cons bananas of piles. I need the total time. Total time is start from 0, then total time plus equal to mat.cell bananas divided by eating speed, right? If the total time is smaller or equal to the hours, we return the eating speed. I think like that's all for the brute force solution. And let's do the time and space complexity analysis, right? This one, because this one will be all max piles time, and this one, because we are loop through the piles, it will be all n time, and this one will be all one space. Overall, for the brute force solution, it will be all max piles multiplied by n time. And because we don't need any extra space, right, it will be all one space. I think like that's all for the brute force solution. Well, the next question is, can we optimize the solution? Yes, we can do that. How? So I will show you how we can solve it using binary search. Cons mean eating speed piles hours. Then we're gonna need to start the left side from 0, right? Then the right side will be mat.max piles, while left is smaller than right. What we need to do is assign the eating speed and starting the eating speed from the middle of the given piles. It will be mat.floor left plus right divided by 2. Then we need the total time. Let total time is 0. We need to look through the piles, right? For cons bananas of piles, total time plus equal to mat.cell bananas divided by k. If the total time is bigger than hours, that means too slow, right? What we need to do is increment the eating speed. The left side will be k plus 1. This one actually is the mid. Then else That means they are eating too fast. We need to assign the right mid. I think this one is enough. Then what we need to return is the left side. I think like that's all for the binary search solution. Then how do I know if my codes are working? Well, let's do the dry run, right? Let's say the given file is 1, 2, 3, 4, 5, and we have around 6 hours, right? Then the left side will be 0. The right side will be 5, right? The mid will be mat.floor. 0 plus 5, which is 5, divided by 2, right? Which is 2.5. Then it will be 2. This one will be 2. So we need to look through the files, right? Mat.cell 1 bananas with eating speed 2 bananas per hour. We will need around 1. Total time right now is 1. Move to the next file, which is 2 divided by 2. We will need around 1 hour. Total time right now is 2, right? Move to the next file, which is 3. 3 divided by 2. We will need around 2 hours. Total time right now is 2 plus 2, right? Which is 4 hours. Move to the next one, which is 4. 4 divided by 2, we will still need around 2 hours. Total time right now is 4 plus 2 is 6. Move to the last pile is 5. 5 divided by 2 is 3 hours. Total time is 9. Too slow, right? So we assign the left side as the mid and v plus 1, right? Which is 2 plus 1. Now the left side is 3. While the right side remain as 5. Let's find the new eating speed. Mat.floor 3 plus 5, which is 8. 8 divided by 2, which is 4, right? I will just copy this. This one is 4. 4, 4, 4, and 4. It will be 1 hour, that is correct. This one is 1 hour. This one is 1 hour. This will be 3. This one is 1. It will be 4. And this will be 2 hours. 6. Okay, so the ideal eating speed is 4 bananas per hour. Is the ideal eating speed for Koko to eat all bananas before the god come back. Then we return 4, right? Okay, which is this. Okay, I think like that's all for the dry run. Let's do the time and space complexity analysis. This one because we are keep dividing the array into 2, right? On the each step, it will be O log max files. And this one, because we are looping through the pile, it will be O n time, where n is the length of the piles. And because we don't need any extra space, it will be O n space. So overall, for the binary solution, it will be O log max file multiplied by n time and O1 space. I think like that's all Let's try on this. It will be let.left 0, then the right side will be, hold on, math.match files, while left is smaller than right. What we need to do is find the eating speed, right? It will be math.floor left plus right divided by 2 for const bananas of piles, let total time 0, total time plus equal to math.cell bananas divided by 8. If total time is bigger than the given hours, we need to increase the eating speed, right? Then else we need to slow down. What we need to do is return left side as the minimum eating speed. So this will be all log max files, max file, and this one will be all and time. So overall for this option 2 binary search is all log max file multiply by n time and all one space. Let's try to run them. Okay, it's accepted. Let's try to submit. Yay! See? And the space is all one. I think like that's all from me. See you next time.